Hello there and welcome to this demonstration video. My name is Chris Jones. I'm the Field Applications Engineer for Secure Thingz. We're based out here in Cambridge in the UK, and what I'd like to do today is demonstrate our Embedded Trust tool, particularly targeting the Renesas RX65N. So for those of you familiar with Embedded Trust tools, I'm sure you'll see this page as quite familiar. So let's go ahead and pull in an example project. So here you can see on example projects there is now a new Embedded Trust category, and we have created here at Secure Thingz a getting started project for you to play with. Let's pull that in to our workspace, and this application here for demonstration purposes is let's take it as the application that you'll be working on for possibly some IoT product, and you want to add security to this IoT product. And what I want to do is show you how easy that is to do using the Embedded Trust tool. So here you go, here's the getting started project. We can have a look at it. It's got quite a load of stuff inside. There's, as you can see, quite a few commands here to reset the board, look at the status of the boot manager, check the signing is good, etc. So quite a few little features there that you can play with later on. So let's take it, this is the project that you're working on, and now what we want to do is add security to it. So the way we do that is we will create a new project for the workspace, and you will see that under the RX there is a new create project available called the Secure Boot Manager. So this is a secure boot manager that has been designed here in Cambridge at Secure Thingz, and what we'll do is we'll add this to our workspace. So what I'm going to do is create a new folder. I'll call it Test RX. This is where we're going to place everything, and the new project is called the SBM for Secure Boot Manager. So that'll open a new space here. You can see here's the boot manager. Here's some readme notes to give you some guidance as to what to do next. I'll bring your attention to this note here that says the E2 Lite that I got plugged into my board has actually been configured to erase the flash ROM before download. This is something we recommend when programming the boot manager into the device, but something you should disable when we're actually going to program the getting started application. So let's just configure our project here. So we'll go to the options and categories menu. Now you'll see that under this menu there is a new category called security. So this is something that you will get with Embedded Trust. So let's first select the device we're targeting. So in this case I'm plugged into a Renesas starter kit for the 65N, the 2 meg version. On that starter kit there is the 565NE product. I'm going to use a E2 Lite emulator for my debugging. There it goes. It's been configured, and now let's configure the security part of the project. So you can see here under the security tab there's Embedded Trust, and I can enable it with this radio button. Now what I can do is create a new security context, so a description for the security that I want to add to this project, or I can add one that maybe I've previously created. We haven't done that today, so let's create a new context. So part of the security context is the information that will be deposited into the device certificate that we will create and program into the device. So this is basically the information that the certificate usually holds. So first of all, let's give our security context a name. So this is a free text entry, and let's target the folder that I created for the RX. Let's put everything in here. The organization, so I'll use Secure Thingz. I am part of applications. Country code, as I said, we're based out here in the UK. Location is Cambridge, and the county is Cams. So that's the information that will be loaded into the certificate. Now we're starting to get into some of the security settings. So you'll see that a couple of here are grayed out. These will be supported in our October release of Embedded Trust. But options we have given you at the moment are the number of certificates. So generally you have 3 certificates that are used for a device. A root certificate, an intermediate, and the device certificate. That represents these 3 certificates here. For the device certificate, there will be a serial number usually put into that certificate. You can either generate a random number for that serial number, or preferably you would like to take the number that's actually on the silicon die that's used in the certificate. So here you can see the default is to take the serial number from the device. But if you don't want to do that, we can generate, or the Embedded Trust tool can generate a random number for you to put into the certificate. But I'd like to show you actually extracting that from the device. So the next category is boot manager settings. So here you can see that we can optimize the boot manager to use any embedded hardware that's on the device. Whether you need an update slot, this means that you can use external devices to put new software updates, so the boot manager can extract them from external devices. Currently we only support an update slot in the flash in the device, so that's set to true. Here you can see full encryption is default. That means that when the image of the application is mastered, we will actually encrypt it. Here are some other options which will be detailed in a future release of the tool. So let's go ahead and create our security context. So you can see here it's created a context profile file, and that holds all the security information, or configuration should I say, for this particular secure boot manager. Okay, let's go ahead and generate the secure boot manager code. Now the secure boot manager code is open source, so you, the customer, can look at all this code. You can go in and change it if you wish. And we have provided several stubs here under OEM for you, the customer, to add any stubs required to handle any failures or any problems that occur. We will hand control over to you for handling in the device. Okay, so this is the boot manager. So what I'm going to do now is I'm going to program it into the starter kit. So first of all, I want to configure the E2 Lite. So we'll take that as default right now. You can see here it says erase flash ROM before download. And what I'm going to do is use this new tab that's in Embedded Trust that you don't see Embedded Workbench, called Security. Under here I have 3 options in this first version. Currently I'm in the Secure Boot Manager, so I only have the provision option. What this will do now is it will build the Secure Boot Manager, it will create the device chain, certificate chain, and program it into the device. You should see here where it actually reads the Silicon ID out of the device prior to creating the device certificate. There you go, it's reading the device ID. It will then take that information and create a device certificate. It will then create the intermediate and the root certificate with the associated signatures required. So it does actually do quite a lot of complex functions quite quickly. Okay, so we can see all the messages there. So that Secure Boot Manager has now been provisioned into the device. What I'm going to do now is go to my user application. So this is the application that you, the customer, will generally be working on. So it's taking a little while just to change configuration. So this is the project. So what I'm going to do now is add security to this project. So to do that, I will go to the project options. Under security here, I will enable that I do want security to be added to my application. I cannot create, but I can add. So what I will do is pull in or import the security context I created earlier. That will now be pulled into this project, and I can now put in the new version of the application that I would like to master. So we'll just call it 3.7.2 as an example, and click OK. Now this project has been associated with that secure boot manager and that security context that I have designed. So our secure manager is configuring the system. I will now look at the hardware setup for the E1 Lite. I will make sure that the erase flash ROM before download is not enabled. And now what I'm going to do is master the application. So what this process does is it takes it builds the project, it will then encrypt it, and it will use the keys for encryption that was developed in the previous security context configuration. So you can see here it's building the project. And the important thing here, I think, is to note is here you can see the getting started S record. So that's the original file image. But here you can see it's shown that it's got the new version, and now it's created a software update package, which is the encrypted version of the S record. And this is called gettingstarted.master.srecord. So this again looks like a normal S record, but the data inside it is encrypted information. Now only the security boot manager that I provisioned into the RX and the previous step can decrypt that file. So let's go ahead and put that file into the device. So I can simply do a download and debug, just like normal workflow of developing a project. What's actually happening now is that S record is being programmed into the RX, into the update slot, not in the correct location for the image, of course, because it's all encrypted. It's being put in the update slot. The RX is then being rebooted. The security boot manager then checks that it has got an update in the update slot. It will then check that update for correct signing, and then if it's happy with that the image is good, it will decrypt it and flash it into the part. So you'll notice that took a little bit of a delay because of all that processing that was underway. So now what's happened is the image has actually been flashed into the device in the correct location, and we can now run it from main. So let's run the application. What I'm going to do now is open a terminal, because I have a USB cable connected to the board, which you can see is now running. We have some commands available. Let me open this up for you just to make it a little bigger. So we can see here, these are some of the commands that we can look at. We can reset the device, look at the keys, etc., look at the public keys. But what I really want to show you is the command C, which is a report on the provisioned identity chain. So let's input C, and now what you can do is see here the information that we've provisioned into the boot manager. So here we've got the serial number of the device, so that will actually be the silicon ID of the chip. That's in the N device certificate. That certificate has been created with all the information that I initially put into the tool. So the organization, the division, etc., and the location. And you can see here that it's put in a time that the certificate is valid. You can see here this will be today when I created this image, and it'll be up to 2029, so 20 years on the certificate. We can change these options if you wish. Here you can see the intermediate certificate, so this one would have been used to sign this certificate, and of course this certificate is the root certificate. So here you can see the full certificate chain. In the directory where we created the project, you can see the .pem files for these certificates, and you can look at more detailed information in those certificates. So basically that's to show you how easy it is to add security, this complex security of certificates and keys, etc., how easy it is to add to your project. So thank you very much for listening. I do hope you found that useful. And if you have any questions, please go to our website. And I hope you have a lovely day. Bye for now.